So hello guys, today I will show to you some problems on chapter 4, which is internal loadings developed in structural members. So the first problem that I will present to you is a problem about internal loadings developed at specified point. Okay, so let's have solve one problem. So here, determine the internal normal force, shear force, and bending moment at point C. Assume the reactions at the supports A and B are vertical. So here, let's draw the beam. Point A, point B, and you have point C. So here, determine the normal forces. Okay, normal forces meaning uh, the normal effect, or let's say at point C, what will be the normal force, okay, which is found here. Okay, so it can be here or it can be here. What will be the normal force? Then the other one, the shear. So if you cut this one, what will be the shear force? The normal force. Then you have also bending moment at C, okay, which is, it can be here, moment. Okay, so these are the unknowns. Okay, so these are the unknowns, but based on the figure, A and B are A and B are having vertical reactions only. So you expect that at point A and B, you have only AY here, and you have here BY. Then, what else? So what we can conclude here is there is no normal force at point A and point B, only the vertical forces. So before we proceed with this one, we should determine first the reactions A1 and B1 before we can proceed with determining the normal shear, determining the normal force, the shear force, and the moment at point C. Okay, so we will draw the free body diagram. So by the way, this is a trapezoidal loading. Okay, which what can we say about this one? You have two locations of the load of 0.5 kilonewtons meter and the 1.5 kilonewtons per meter. Okay? Where's my calculator? Okay? So you have here AY, you have here BY. And of course, this is 9 meters, and this loading can be divided into two. Okay? One which is triangle and the other one is rectangle. So if this is 0.5, this is 1. Okay? So you have here point C, right? Point C located at 3 meters. So the first loading will be located at 4.5 meters, which is 0.5 times 3 plus 6. Okay, for this rectangular section. And the other one is located at 1/3 of 9 meters, which is 3. You have here another, this is 1/3 of 9, which is 3 meters. This is for the triangular loading, which is 1/2, 9 times 1. Okay? So in other words, AY, BY, this is 0.5 times 9 is 4.5 kilonewtons. And you have here another one, which is it 2? Ano? It's also 4.5. Okay? And this 2 is located at 4.5, and this one is located at 3 meters. So now, to determine the reaction, you can have here summation moment at point B is equal to 0. Assume clockwise, positive. So AY times, this is 9 meters, times 9 minus 4.5 times 3 minus 4.5 times 4.5 is equal to 0. AY times 9 minus 33.75 is equal to 0. AY is 33.75 over 9 kilonewton. This is kilonewton, sorry. So AY is 3.5 kilonewton. This is for AY only. Now, to solve for BY, you can also get summation moment at A. So go to 0 plus. Here, you can assume any direction. So, negative BY times 9 plus 4.5 times 4.5 plus 4.5 times 6, because this is 6 already. Okay, can you see it? So negative by times 9 plus 47.25 kilonewton is equal to 0. So by is 47.25 over 9 kilonewton. So by is 5.25 kilonewton. So if you are not sure whether your reactions are correct or not, you can have here summation forces along y is equal to 0, upward, positive, ay minus 4.5 minus 4.5 plus by is equal to 0. So 3.75 minus 4.5 minus 4.5 plus 5.25 is equal to 0. Is it 0? Yes. This is 0 is equal to 0. Therefore, our reactions are correct. Now, you can proceed with isolating or by getting this one. I mean, having the free body diagram, this one. Okay? So, what will happen is that when you cut that one, so here we can now solve, so, free body diagram of beam AC. So, what will happen is that dy you have here normal force at C. You have here C. Then you have also moment at C located at 3 meters. This is 0.5 kilonewton per meter. This is Y. We don't know this one. So how to determine the value of Y? By ratio and proportion. Okay? By ratio and proportion. This is 1. This is 0. 9 meters. And how about this one? Let's say this is let's say this is Y and this is Y bar. Y bar is Y plus 0.5. Okay? And of course, to do that, this is Y and this is 3 meters. Yes? Yeah. So, Y is to 3 is equal to 1 is to 9. Y is 0.3. 0.3 kilonewton per meter. 1:9 and y:3. Sorry. Point. My God, I'm not good. This is 0.33. Okay, not 0.3. So now, y bar is now 0.33 plus 0.5, which is equal to 0.833 kilonewton per meter. Okay? So, to continue with that, we can now isolate. This is, what is this? AY is 3.75. Then you have here two loadings, the same with this one, right? At the middle, which is 0.5 times 3. And the other one, which is 0.5 times 3, because this is 0.5. 0.5 times 3 located at the middle. The other one is 1/3 of y times 3. 1/2, sorry. Okay, 1/2. So this is BC, moment at C, and you have normal at C. The total length here is 3, but this one is located 1.5 meters, and this is located what? 1/3 of 3. Okay? Still visible or not? Okay? So, I think it's not enough. You can use another paper. So, from that, we will zoom, zoom. This is 3 meters. This is 3.75. This is 0.5 times 3. And this is 1/2 of y, which is 0.333. 0.333 times 3, and this is moment at C, shear at C, and normal at C. So this is located 1.5 meters. This is located 1/3 of 3. So 1. Okay. So you can now use summation forces along x is 0, positive, and C is there any reaction along x? Is there any reaction along x? So it's 0. Summation forces along y is equal to 0 plus 3.75 minus 0.5 times 3 minus 1/2 of 0.333 times 3 plus shear of C is equal to 0. 3.75 minus 2 plus BC is equal to 0. 1 point, is it 1.75? 1.75 kilonewton plus BC is equal to 0. So BC is negative 1.75 kilonewton, means the assumption of BC should be like this. Okay, so this is okay, but the better way to present that one is BC is 1.75 kilonewton. Sorry, downward. Okay, how about for moment? Summation moment at C plus minus MC plus 3.75 multiplied by 3 minus 1.5 times 1.5 minus, what is 0.333 times 3 times 0.5 is 2. This is 0.5. This is 0.5. This is 1.5 minus 0.5 times 1 is equal to 0. Negative MC plus 8.5 kilonewton per meter, because this one has kilonewton and this is meter, this is kilonewton, this is meter, this is kilonewton, and this is meter, equal to 0. So MC is 8.5 kilonewton per meter. Okay, so we have now already the value of the normal force at C, the shear at C, and the moment at C. Again, let's have a recap. Determine the internal normal force, the shear force, and the bending moment at point C. Assume the reactions at the supports A and B are vertical. So you have here beam with a you have here a you can consider any type of material. It can be beam or girder supported by another beam, okay, or it can be slab supported by two I-beams. And of course, the assumptions are for A and B, these are vertical reactions only. Then you have also trapezoidal loadings, which has a 0.5 kilonewtons per meter at the left and 1.5 kilonewtons meter at the right. So, having this said, before you cut the section at point C, you determine first the reaction at AY and BY using moment. Okay? AY is 3.75, BY is 5.25 kilonewton. And to check that one, you can have summation forces along Y. And if this is the same, since the structure represent a equilibrium condition, the summation forces along Y should be 0. Now, to determine the unknowns at point C, you can isolate this part. Move here. You have your AY, 3 meters. Then shear at C, normal at C, and moment at C. Then, of course, it has the same pattern, which is 0.5 kilonewtons per meter, and value of Y, which is value of Y bar, which is Y plus 0.5. This is 0.5 Y. So to get the value of Y, y over 3 is equal to 1 over 9. 1 over 9 meters. Y is 0.33. So, y bar, this one is y, plus this is 0.5. This is 0.833. So, having this figure now, you can simplify it. So, 0.5 times 3, located at the middle, 0.5 times 3. And here, this is triangle, 1 half of y times 3, 1 half of y times 3, which is located at 1/3 of the 3, because this is triangle. The centroid of this one is 1/3 from this side. Okay? So, this is now the simplified one, 3.75 AY. You have the total length 3 meters. You have point C. Okay? 0.5 times 3, 1.5 located at the middle. 1 half of 0.33 times 3 located at 1/3 of 3. Then, summation force along X and C is 0. Summation force along Y. VC is negative 1.75, meaning our assumption for BC is not upward, it should be downward. Okay? And the moment at C, get the summation moment at C, it will be 8.5 kilonewtons per meter. So, thank you for listening. So, I will present another problem. Okay? Thank you.